transformer. Okay. So the construction of transformer. The transformer contains these are the parts of the transformer. Okay. It contains magnetic core, primary and secondary winding, an insulation of winding, expansion tank, lead and tappings for coil, tank, oil and cooling arrangement, bus hose relay, and silica generator. Okay. Whereas the relay is not shown in the diagram. Okay. Other parts are not you can able to see. So on that day we had seen the principle of transformer. So the transformer works on what principle? Faraday's law of electromagnetic induction. So it works on mutual inductance principle. Okay. So what is the working principle of transformer? So mutual inductance. That is nothing but Faraday's law of electromagnetic induction only. Right. So the mutual inductance in the sense, see, transformer it does not have any moving parts. Like a DC machines, your machine or a motor or generator, something rotor will be rotating, right? Which is known to be a moving part of the machine. Okay? Here we don't have any moving parts in the transformer. All the parts are static. None of the parts will move here. Okay? So transformer is a static device. A static device. Which is a power transform device. It transforms the power. It transforms what? It transforms the power. Okay, what is power? P is equal to V into I, right? So the power transforms is nothing but whatever power available in the primary winding will be transformed to the secondary winding. So I can say that V1 into I1 is equal to what? V2 into I2. Nothing but whatever winding power I have in primary winding, that will be transformed to the secondary winding. So if we take a diagram, so this is primary winding, right? And this is secondary winding. So whatever power available here will be transformed here. So when I connect load here, current will flow to the load. Okay, right? So this center part is nothing but this one. Winding only given like this, primary winding and secondary winding. The windings will be mounted on the core of the transformer. Core is nothing but the center part of the transformer, right? So this one is nothing but your core of the transformer. The core is surrounded by the tank of the transformer just for the protection purpose. Okay, the core will emit too much of heat. Okay, so that heat I cannot keep it open so that it goes to the environment. It is not safe for the core also. So in order to protect the core of the transformer, so what I am doing, I am just covering the transformer with a tank, right? Just if too much of heat is emitted, I just cover it. What will happen? The center portion will be surrounded by more heat, right? So it will always generate heat. And it is you perfectly seal it. It will protect the core. No, it will damage the core only because it is fully surrounded and the heat will damage the core. Okay. In order to protect that, I am filling the tank with the oil. Okay. I cannot fill it with water. So what I can do is I can fill the tank with oil. Okay. So that I have a core. I have a protection tank around the core, and the gap between core and tank is filled with the oil in order to cope up with the heat generated by the core. Okay. Right. So that is what it is filled with the oil. And we do have an extra expansion tank which is known to be the extra tank, or it is also called as a conservator. Expansion tank is also called as conservator of the transformer. Okay, so which will contain some oil. Okay, when this oil is getting, what will happen? As days pass away, heat is generating too much. Oil will drain out. Yes, so expansion tank is also filled with oil so that it takes care that transformer tank is always full. The oil in the transformer tank does not get reduced. If it reduces the tank from the oil, expansion tank will come to the transformer tank. Okay, that is why it is known to be extra oil kept in expansion tank. Okay. We do have a breather. A breather is filled with the silica gel. A breather is nothing but what is meant by breathing? Taking air inside, right? So inside or outside, whatever. This is going to be breathing in or breathing out, right? So breather gives the air supply and we fill with silica gel because silica gel absorbs the moisture in the air. Air always contains some moisture. The tank has always heat, so moisture cannot enter inside the tank. So what will happen? I am putting some chemical thing which is known to be silica gel. It absorbs the moisture in the air and just allows dry air inside. Okay, right? So this is what the construction of the transformer. I hope you understand. Magnetic core is a core which is the center part which is made up of magnetic material, that is what is known to be magnetic core, right? And we do have windings called primary winding and secondary winding, right? And insulation of windings, the winding is always insulated by using any insulation. Mostly paper is the insulation which will be used in the transformers. Okay, right? Expansion tank is a tank which contains extra oil that takes care of the always transformer oil is full. Okay, right? Tank, this is tank oil cooling arrangement, and cooling arrangement is nothing but this oil only. Okay, right? And some very big transformers have a separate cooling arrangement which is kept at the side of the transformers, whereas a small transformers does not have that type of cooling arrangements. Okay, right? Buzzwords relay also, it is present in a very big transformer which is in the power station and not in the street corners. The power stations we do have a very big transformers, right? There we do have a relay. What is meant by a relay? Actually it is a switch or something, but here Buzzwords relay is used to keep alarm. Okay, we do have like if the oil is getting reduced, it will switch it to some other, actually the extra tank will be kept. That is what relay, switching from one to another is going to be relaying. Okay, you pass a relay, right, by playing. Relay is what? Passing from one person to next person, right? Similarly, here when is something filled, it will pass it to the next time. That is why we have here Buzzwords relay with the alarm setting. Okay. Have a silica gel breather. Silica gel breather is what? A breather is filled with the silica gel, so which absorbs the moisture in the air. It absorbs the moisture in the air and allows only the dry air that flows inside the transformer. Okay, right? The construction part is clear. Once again, we will review the working principle of the transformer. Okay, so now we are seeing single phase transformer. Okay, right? So shall we move on to working principle of a transformer? So what principle it works on? Mutual induction principle. Okay. So let us take this is primary, this is secondary. Where it is? The primary winding is wounded here and secondary winding is wounded here. Okay, right? So the magnetic core, there are two types of magnetic core. Three types actually. One is L stamping. So magnetic core, there are two types. One is so like this maybe, or which is nothing but the stamping is L stamping. This type of stamping is known to be L type of stamping. There are three types of stamping, L, I and E. Right? So this type of stamping is L type stamping, which is nothing but the center core part can be made up of two L type stamping. It is made up of this two L type stamping kept like this. Arrangement will be like this, so that it forms a rectangular shape. Yes, it forms a rectangular shape. So then what will happen? A binding can be mounted on this. So this is the center core which one core type which is core type, and this is again it is a core, a shell type core transformer. Okay, right? So here where the primary winding is wounded, this part. Secondary winding is wounded at this part. Similarly here. Here the primary winding, secondary winding both will be wounded on the center. Okay, but it is isolated. So primary winding like this, and secondary winding like this. Okay, so which is wounded on the center, but which will be isolated from each other. It does not have any connection between primary and secondary parts, which is always isolated. Okay, so it is isolated. Similarly there. Okay, right? So here these two parts will protect the transformer windings. So this two is to what? To protect the winding which is at the middle. Okay, right? So how many types of core are there? Two types. Stamp means three types. Stamp means three types. This is stamp means. Core is two types. One is core type, another one is shell type. To use core type, I use two L type stamping. To use shell type, I use one E type and one I type stampings. Okay, right? So this is what about magnetic core. So I think primary and secondary winding are not clear. We use any copper thin winding, thin wire to give a winding in the transformer. Okay, copper thin wire is used for the winding purpose. Okay, next is insulation. I told we use paper insulation between the windings. Okay, and expansion tank. You know what is expansion tank? Everything is clear, right? And cooling arrangement and the relay and all is not shown here, which is used in the bigger transformers. Okay, right? Power is what? V1 into I1 is equal to V2 into I2, which is nothing but power in primary is equal to power in secondary. V1 is voltage in primary, I is current in primary, V2 is what? Voltage in secondary, and I is current in secondary. So this is V1, this is I1, this is V2, this is I2. I2 flows through the load. Okay, right? So that is what. And we don't have any connection between primary winding and secondary winding, which is known to be electrically isolated. This you should write it as electrically isolated and magnetically coupled. The windings are what? Electrically isolated and magnetically coupled. What is meant by magnetically coupled? So due to flux which is induced in first, the same flux will be induced in the second, right? Which is nothing but the flux will be induced over here. This flux will be combined in, that will combine primary and secondary. Due to the flux, what will happen? The voltage in primary will go to secondary. Okay? So which is electrically isolated and magnetically coupled. Okay? Right? So I can write V1 by V2 is equal to what? I2 by I1. Yes, can I write like that? V1 by V2 is equal to I2 by I1. Okay, right? So take it as equation number 1, which says that in secondary, when the voltage increases, current will get decreased because both are indirectly proportional. It is not direct proportional, it is indirect proportion. So what happens? When the voltage increases, current will get reduced. Or when the current increases, voltage will get reduced. Okay? So that is what your principle in secondary. It is not directly proportional. Voltage and current in secondary is inversely proportional. Okay? Because to make the power common. Suppose if I have voltage V1 is equal to 100 volt, I1 is equal to 1 ampere. What is the power? V into I. 100 into 1 is what? 100 volt ampere. So power is 100 volt ampere or 100 watt in order to make the secondary power equal to the primary power, I2 should compensate itself, it should reduce itself, which makes the power equal. Okay, so I2 will be now 0.5 ampere. Now 200 into 0.5, 100 volt ampere it will come. Okay, V2 is again what? 200 into 0.5, 100 volt ampere. Voltage increases, current should get reduced to make the power equal. You understand? Suppose if voltage V2 is 50 volt, what happens to power? I2 becomes 2 ampere, so the power always remains at 100 volt ampere. Power should be equal, that is the concept. In order to make the power equal, voltage அதிகமான current என்ன பண்ணணும்? Reduce பண்ணணும். அப்பதான் multiply பண்ணும்போது I will get this power. Okay? Otherwise, voltage reduces, current must be increased in the same factor so that power remains constant. Okay? So, always remember P1 should be equal to P2. Okay? So, in secondary winding, if voltage increases, current will get reduced. To make what? Power equal. Okay? Right? So, that is what the working principle. Move on to the EMF equation of the transformer. So EMF equation. Shh, don't talk.
Voltage and current is constant. Degrees of leak is
It is not necessary that something should be constant. Here power is constant. Yes, power is constant. In order to make power constant, voltage and current are adjusting itself. One is increasing, other will decrease and make the power constant. Okay, right? Now EMF equation. So write down the Faraday's law of EMF. Faraday's law of equation. What does the Faraday's law says? Induced EMF is proportional to rate of change of flux. Okay. So induced EMF is proportional to rate of change of flux. That is what Faraday's law says. Okay. Right. When there is rate of change of flux, and EMF will get induced. Okay, right? So E is proportional to what? d phi by dt. Okay. So when I remove this proportionality, what should I use? I should use proportionality constant. So I can put k. Instead of putting k, I can take k value is equal to 1. So the proportionality constant is 1. So it takes E is equal to d phi by dt. Now I should just find out the value of d phi and dt and substitute here. Okay, right? Shall we do that? Taking the rate of change of flux. Taking the rate of change of flux over time, right? So we will write this d phi dt. So d phi is rate of change from the flux from 0 The rate of change of time is reaching a maximum value, how much time it is taking. For reaching a maximum value from 0, how much time it is taking? T by 4. Okay. So the rate of change of time is what? T by 4. Okay. Clear? Reaching a maximum value, how much time it is taking? 1 by T is equal to 1 by F. Right? Time is equal to 1 by frequency. Inverse of frequency. So I substitute T 1 by F. So I can write it as 1 by 4F. Right? 1 by 4 into 1 by F. Which is nothing but 1 by 4F. Okay? So this is your, substitute those two values over here. So that will be equal to 5m divided by 1 by 4f. We take the 4f to the numerator, which is 4f into 5m. So E is equal to 4f into 5m. Okay? That is actually 5m. Okay? E is equal to 4f into 5m. Another term, form factor is equal to RMS value divided by average value. Form factor is equal to RMS value divided by average value. Form factor is nothing but your FF. Okay. Form factor is equal to average value, don't divided by, sorry, RMS value divided by average value, right? This is what your average value, 4 pi into Fm is your average value, okay? So that is your RMS value is always 1.11, right? So 1.11 into 1. Form factor is always 1.1. So RMS value you need to know, that is divided by 4f into 5m. So RMS value is equal to 4.44 into f into 5m. So the form factor for a AC signal, transformer always works with AC. Okay. So the form factor for a AC signal is what? 1.11 always. So replacing form factor is 1.11. Average value is, average EMF value is 4f into 5m. Okay. So when I multiply that, it is 4.4 into f into 5m is your RMS value of form factor for AC signal is 1.11. Okay. But we have a small thing for that in unit 1. Form factor we already know in unit 1 it is 1.11. So we just substitute here and get the value.